A tiny startup just released an artificial intelligence model that defeated the most powerful tech monopolies on Earth. It was built by Sakana AI, a small research team based in Tokyo. Their new model is called Fugu. Fugu is incredibly small. It contains just 7 billion parameters. In the AI world, that is a microscopic footprint. To put that in perspective, the industry giants it competed against are built on hundreds of billions, or even trillions of parameters. They require massive server farms and astronomical budgets just to function. This sets up a genuine mismatch. If the industry's most basic assumption is that bigger models produce smarter results, Fugu is an anomaly that shouldn't be possible. To see why it's being taken seriously, we have to look at the scoreboard. We can start with the hard evidence. The most grueling test for a coding AI right now is SWE-Bench Pro, which forces a model to solve real-world software engineering problems. This chart shows the latest SWE-Bench Pro scores. Fugu Ultra sits at the very top, with a score of 73.7, beating Anthropic and OpenAI. The test requires navigating massive code repositories to hunt hidden bugs, yet GPT-5.5 fell behind Fugu here. Remember, the companies building those larger models operate with endless capital and sprawling physical campuses. Sakana accomplished this with a fraction of those resources. When a 7 billion parameter model outperforms the giants on their own coding tests, it proves that raw compute and massive scale are no longer the only viable path to artificial intelligence. So how exactly did this tiny 7 billion parameter model pull this off? Fugu isn't generating the final answers itself. It operates as a project manager, using a technique called multi-agent orchestration. Given a complex prompt, Fugu breaks the problem down into actionable subtasks. It dynamically sends those pieces to a hidden pool of frontier models, choosing the best AI for each job. Finally, it synthesizes the verified code into one cohesive answer. The model's real intelligence isn't memorizing the solution, it's knowing exactly who to ask and how to coordinate their work. To see exactly how this orchestration plays out in practice, researchers gave the AI a highly specific challenge. They asked it to write a Python program from scratch to solve a Rubik's Cube. Large single models typically struggle with this kind of test. The multi-step spatial logic required is incredibly difficult to map out in one straight shot. When they ran the test, the monolithic models shipped code that crashed and failed to produce valid solutions. But Fugu successfully wrote a solver that optimally completed 300 out of 300 random scrambles. A collaborative, verified team of agents can navigate complex reasoning much better than a single model working alone. But the engineering community hasn't universally embraced this victory. The immediate pushback was that Fugu is essentially an API wrapper. Because it uses other models to do the heavy lifting, critics argue it quietly relies on the exact same giants it claims to be defeating. And that brings up a serious transparency issue. The way Fugu routes its tasks is a black box. The underlying model that actually produced your answer is completely hidden from the user. The model pool is also fixed. If an enterprise user needs to exclude a specific AI provider to meet data privacy or compliance rules, the top-tier version of Fugu doesn't allow them to opt out. Add to that the fact that the benchmark scores are entirely self-reported. Sakana used a specific testing harness rather than running a controlled head-to-head environment evaluated by an independent third party. The orchestration technique clearly produces strong results, but the lack of transparency keeps it from being a flawless, undisputed win. If you look past the flashy benchmark scores and the wrapper debate, you find the actual long-term value of this system. Recently, US export controls forced Anthropic to pull some of its most powerful models, like Claude 5.5, from global markets. Access vanished overnight. Building on a single model creates a massive vulnerability. If your vendor goes dark, your entire system breaks. But an orchestrator solves this. When a primary provider gets restricted, the system bypasses the failure, automatically rerouting tasks to other available models. Sakana's Fugu provides a blueprint for keeping businesses online. It proves dynamic orchestration can protect users in a landscape dominated by unpredictable vendor monopolies.